All right, so we're going to take the chapter 8 and 9 exam. I understand totally that we haven't yet covered chapter 9, but I was looking through the timing, and I'm also I just simplified the test to make it where it covers basically what we have covered so far. I'm doing this very intentionally because of not having power today. I just think it's the best adjustment for what tools I have and not wasting a full day. And I think you'll ultimately like it because I made the test everything we can cover so that we can do so far. So here's what I'm going to do. I'm going to go through this lesson. We have on this review, I'm going to go through quickly how you would do. I have, I think, was it 15 or 17 problems? 15. I have 15 listed here. And we're going to go through some of these 15. If we can do all of them or we do just do some of them, you can tell me as we go. But I'm going to show you how to do it, and we can take this test. This test you can retake up to 10 times to make sure you get the best possible grade. All right. What you're going to want for this test is the calculator. So if you go to your Google Classroom, so when you log into your Google Classroom, I want you to go to classwork and click here the chapter 8 and 9 exam. When you open this up, I want you to open up this calculator right here. That's the calculator we're going to be using for most of this test. What we've been talking a lot about is polar in the terms of magnitude and direction. And then we've had rectangular, horizontal, and vertical. And I'm going to, add that so we know what's what. The R is considered magnitude. The theta is considered direction. And over here, I'm going to do the same thing. X we call the horizontal component, and Y we call the vertical component. Now yours isn't updated yet, but I'm going to load this in just a moment. So vertical, and now up here, I need to change this to magnitude, and this one to direction. So that we can make more sense when I use the proper vocabulary, you can make more sense of all this. Okay, so what we have here is this calculator that's going to convert from polar points to rectangular points. Okay, I try to simplify it to where we can just use one graph for all this. If you scroll all the way down, I explain the math. This is just the process of how the math is found. But up here, the calculator itself is the polar point and the rectangular point. That's basically the math I want you to see. So I'm going to copy this. I'm going to put this update real quick. If you come in here and refresh your page and open that link, that should now work for you better. And also, let me come over here. Whoops, that wasn't supposed to happen. That's the wrong one. Let me go over here to our calculators, and I'll update this link as well. Desmos graphs, this one. Get link. One more time and I'll be done updating this. Okay, so let me start over again here. If you open up your chapter 8 and 9, make sure you refresh this page if you already opened it, and I want you to click this pre-program plotting polar coordinates and conversion calculator. When you refresh it, you should see the same calculator as me. All right, so when you refresh it, you should get the same calculator. What I want to show you is how we can convert from one set of points to another. So on number 1 on this test review, I have 3 of these just to let you know. What I've given you on this, if you read the instructions, it says find the rectangular coordinates of the point given the polar coordinates. And so I have 3 separate polar coordinates. I want you to notice that these two have terms of pi, which are radians, and this one's in degrees. for my calculator, what you'll need to do first and foremost is convert to the correct mode. So I'm looking around. You have not noticed this yet because we haven't gotten to chapter 9, but this is called a polar graph when it's circular. Many of you have probably seen a movie where you've had like radar on it. That's a perfect example of what is in polar coordinate graphing form. Okay, but what we have here is an y-axis, an x-axis, and this is the polar graphs, these circulars. So on this problem, I'm going to go to radians first because I need to change these degrees to radians. So I'm going to hit the setting in the top right and choose radians. So I'm going to have you do that as well. Choose radians. And when you choose radians, now I have radians going around these circles. My first point is 1 comma 3 pi over 2. What you would do for this is, since it's in polar and we're converting to rectangular, is you would go to the polar and you would type in 1 and 3 pi over 2. 3 over 2 pi, I think is actually how it's written. Let me see that again. Yeah, it was 1 comma 3 halves pi. So I have 1 and then 3 halves pi for the theta. What happens is you see that this is graphed here. Let me zoom in a little bit at that point there. Now you can click on it and it'll convert it to x and y, or the other thing is over here I have a rectangular point, and this one you can actually drag. You could drag until it's right on top of it, and you would see the point is basically, I didn't drag it right on top, but it would be 0, 1 as well. So this point you can drag if you want, but the easier is just to click on it right there and you can get the exact point. The answer would be 0, negative 1. So the answer in this one would be D. Let me see how well this will write. I have not used this zoom tool before. There we go. And so that's the answer to number 1. So let's try number 2 now. Number 2 says that we're looking for 9 comma pi. So I'm going to come back to my calculator and I'm going to change this value to 9 and pi. So polar point, it's given as r theta, and that's what I'm plugging in, the r and the theta here, 9 pi. And so when I do that, we get a point. Let me zoom out a little bit. There it is. We get this point there. If you click it, this would be negative 9 comma 0. So the answer on number 2 would be negative 9, 0. This one right there. And now I'll try number 3. Now number 3, notice that this angle is given to me in degrees. So I'm not working in radians anymore. So the first thing I need to do when I come back over to my calculator is change my mode back to degrees. So I'm going to go to the settings in the top right and change the degrees. This value was 8 comma 270. And so my magnitude is 8. My angle is 270 degrees. So when I convert that, I'm going to zoom out a little bit, and there's the point down here. I'm looking for that purple point. I see it. It is 0, negative 8. So the answer in this one would be B, 0, negative, or no, not B, I'm sorry. It looks like D, 0, negative 8 right there. I know, unfortunately, my my smartboard, I don't have the tool to make this go away right now at home. And so you're just going to have to deal the best you can with me, but the answer on this one would be 0, negative 8 right there. So do you have any questions for converting from polar to rectangular, how I just did that? Okay, so I'm not getting any questions. Everybody okay if I move on?
Yes.
Yes.
All right. So you will have, out of the 10 questions, there are like, I think, 4 portions of questions. I'm not going to tell you how many you'll have on each one, but that's one of the 4 portions of test questions. All right, let's see the next portion. The next portion is I'm going to give you rectangular, and I know this is rectangular because there's not an angle symbol on the right side. So these were polar. I knew that because it was either in degrees or it was in terms of pi, and that means it's polar, and I converted to rectangular. you will have one portion where I give you what's called rectangular. So notice there's no angle here. That's just a number, -2. No degrees, no pi symbols. So this is rectangular, and you have to convert to polar. So we'll still use the same calculator. What I'm going to do here is refresh this. And this time, what I'm going to do is I'm going to plug in the point to the rectangular portion. So in the first one, it said 2, -2. 2, -2. And so I typed this in to rectangular point. That's the point. Now I want to find the polar point that would overlap here. Unfortunately, you can't just click it because Desmos will always give you the rectangular form. So this time around, I'm going to have to just plug in, guess, and check until I find the one that overlaps. So the first one here is 2 square roots of 2 and 225. I'm going to check my mode. I am in the correct mode. I'm in degrees. So my magnitude here that I'm trying is 2 square root of 2 and 225 degrees. You can see that does not overlap. So at this stage, we can say for sure that anything with 2 square roots of 2 and 225 is out. And a lot of times you'll have multiple of these. That's different. That's not the same. So we'll check this one in a second. But A is out for sure. That's the only one I see that matches there. So now let me try B. B has 2 square roots of 2 and 315. So that's what I'm going to try now. 2 square roots of 2 and 315 degrees. So I have 2 square roots of 2. I'll try 315. 315. Okay, this overlaps, it looks like to me. You see how they overlap one another? So that's a good one. This answer is looking pretty good. Let's test it by trying this angle as well. -2 square roots of 2 and 135 degrees. So now I'm going to try -2 square roots of 2 and 135 degrees. And again, you can see that they overlapped. Whenever I flash this, you can see that that point is flashing. I flash that point over there. So we have found the correct. You could, by the way, you could flash either one of these points on the left side, doesn't matter which one, but you'll see the point flash when you do that. So B would be the correct answer on this problem. Now, if you wanted to do the algebra, by the way, I have the algebra rules written. The algebra rules written, whoops, over here are what's under this portion on the left side. It says to understand how to plot this in algebra, it's helpful to know the connection. And I just walked through the math that you start with cosine being x over, and instead of hypotenuse, since I haven't talked through chapter 9, you haven't learned why I use a r, but it's the same thing as a hypotenuse. You start with this relationship that we learned all the way at the beginning of this semester, that cosine is x, sine is y, and you isolate the x and y by multiplying the denominators. And so we end up with this relationship. R cosine is x, R sine is y. Now, whenever you plot, we normally say a plot is x, y, but now that we know x is R cosine, x, y becomes R cosine, R sine. And that's how you would plot the point. That's the math of what I have written right here, R cosine, R sine. Also, if you were given rectangular and you want to convert, like we are in the second section, what you would do is the R is, it's the Pythagorean theorem here. You take the square root of x squared plus y squared. So that's what my calculator is doing. And then the theta is the inverse tangent of the y over x. If it's in the first or fourth quadrants. If it's in the second or third, you'd have to add 180 or pi. So anyways, that's what my calculator is doing. So that's just over here, these notes, is if you want to do an algebra, that's the algebra you need to know. But over here, my calculator is doing all that for us. All right, so let's try another one. We figured out number 4. Now let's try number 5 here. It says, here's your rectangular point. We know it's rectangular because there's no angle symbol there, no pi. So we're looking at -2, 0. So I'll plot -2, 0 as a rectangular. -2, 0. And by the way, one way of kind of cheating a little bit, oops, is if you look out here, you can see that this is on the second circle. So now let's walk you through a little cheat. It's on the second circle, which means the R you can kind of figure it out, is radius. Since you're 2 circles over, the radius is 2, and it's on 180 degrees. It's on that line. So that's going to be a cheat. If you are a quick learner, a quick study, you might figure out, okay, the answer I'm going to be looking for will be, since it's on the second circle, R will be 2. And since it's on the 180 degrees, that's going to be my angle. So I look at my options, and I see a 2 180 right here. So I'm going to go ahead and try this one. If I put in 2 and 180, you can see once again that that point is overlapped. And in polar, we'll learn that every point, there's 4 different ways you can write it. Let's try this one. Let's see if -2, 0 overlaps. -2 and 0 degrees. Once again, it overlaps. So that's the correct answer. On this problem, B would be correct. That would be the correct answer. All right. Now let's try number 3 here. Not number 3, I'm sorry, number 6. We have 5 square root of 3, comma 15. That's a rectangular point. 5 square root of 3, comma 15. When I zoom out a little bit, I see this point. To use the cheat, I see it's on 60 degrees, and you could count how many circles out there it is. So this is 15th circle, this is the 20th circle. So if this is 15, 16, 17, it looks like it's going to be between 17 and 18 on 60 degrees. Oh yeah, that won't show me anything. So when I look at my options, okay, I guess that's 10 squared 3, but I'm looking for 60 degrees. So I see this one has 60 degrees. Let's see if C is going to be the correct answer here. 10 square roots of 3. Whoops, I typed in the wrong spot. That's the theta. 60 degrees. And we're getting 10 square root of 3. As you can see, that does overlap. And so let's test it, because you can see that this option did have a 60 degree as well. But so let's test it to make sure that C is the correct answer. I'm going to test it with -10 square root of 3 and 240. -10 square root of 3 and 240. And you can see once again they're overlapped one another. So C would be the correct answer on this one. Any questions on section 2?
No.
Okay, hopefully we're doing all right. Let's take a look at section 3 then. So section 3 has to do with graphing. You haven't seen how to graph polar, but polar makes some very cool curved graphs. So how do you graph polar? You can use this same graph here, but what I'm going to do is, let me just to make it simpler, I'm going to put a 0 here and a 0. For a polar graph, it might be easier just to have a blank calculator. Let me just go blank so we're not confused. For a polar graph, I'm just going to get it this blank. So I have a blank graph. What you do, oops, wrong one, is you type in your equation, and if you type it in with the R and the theta, it should give you this graph. You must use R and theta. So this says R equals 1 plus 3 sine theta. So I'm going to type that in. R equals 1 plus 3 sine theta. And you see you get this graph, and you can look at it and compare it. That looks pretty good. I'll tell you the first answer choice right here looks pretty good. I'm going to lean towards guessing this is going to be the correct answer. If you want to try the other ones just to see what they would look like, we can do that. So we have 3 plus sine theta. Let's try 3 plus sine theta. R equals 3 plus, come on, what's going on? Sine theta, you can see that is not even close. So B is not going to be the correct answer. That's not even close. Let me Remove that circle off there. Okay, so we still think the answer is A. Let's now try C here. 2 plus 2 sine. Two plus 2 sine. I click this one. Okay, I see that this one's closer, but it's still not the right graph. It's not overlapping. So it's not going to be C either. And then 1 plus 3 cosine. 1 plus 3 cosine. Graph this one. Oh, it's the correct shape, but it's turned on its side. So that wouldn't be the graph either. The correct answer in this one is, in fact, A. So you will have a section where you have to graph polar graphs. Any questions over that?
As long as we graph the options, right?
Yeah, you just graph the options, see which one matches. Make sure you use an r and a theta. This will not work if you use y and x's. Let me show you that. So that's the correct answer. Let's try it. What if we would have typed in y equals 3 cosine x? What would have happened? Not it. So you got to make sure you type it in with the correct letters. So Desmos will work well for you there. Okay. And now polar distance. So there is one type of problem. It says the locations given in polar coordinates of two ships are given here. Find the distance between these ships. Now this is going to be a separate calculator. Okay, so I have a polar distance calculator. Let me go to my pre-programmed list. I forgot I had these on there. I should have added it in this line, which I will do that in a second. If you open this up, I do have a polar distance. So I'll add this into the recommended. It's polar distance. It's the distance between two points in polar form. Where is it? It's graph number 30. So I'll open this up. And what's going to happen is we're going to plot 2 points and see the distance between them. So on number 8, we have 6, 10 degrees and 4, 70 degrees. So I'll come over. My first point is 6, 10 degrees. 6, 10. And you can see how polar graphs finds 10 degrees and it goes 10 circle, or this one goes 6 circles out. 1, 2, 3, 4, 5, 6. The other point is 4, 70. 4, 70. And so this one would be just past 60 degrees. There's 70 degrees, and it's on the 4th circle. And then you have to find the distance between them, the two, which the distance is shown right here. It would be 5.29. Looks like the answer is C. And let's try it again. Number 9. The locations given in polar coordinates of two planes approaching an airport are 2, 18. Let's go 2, 18 degrees. And make sure you're in the right mode. So this one's in degrees. You can see going around. These are all degrees, and that's what our problem is. So there's one airplane, 2, 18. And the other is 8, 84. 8, 84. And you're seeing how radar works. Oops, if you've ever seen a movie with a radar system, that's what the math is. So we're looking at the distance between these two. Notice this point would be at 84 degrees, almost 90 degrees. And this first point was up only 18 degrees from the positive x-axis. The R refers to what circle it's on. This is on the second circle. That's the radius from the origin. And this one was on the 8th circle out. 5, 6, 7, 8. That's what the R, that's why they use the letter R for polar. So anyways, the distance on this one would be 7.41. Or I guess I rounded improperly. So it would be C. 7.415, which would round to 7.4142. So the answer would be C here. Any questions over polar distance?
No.
Okay, let me come back over here and I'm going to add that to your instructions. Highly recommend using the polar distance calculator. I want to just directly link these on these instructions so that there's no confusion. So the two calculators I've used are linked right here. Those two. Those are the two calculators I've used today. Okay, let's go check on. So this, I was including this when I said 4 sections. I was including it with the graphing. So I know this one only had one problem. Over here, this has 3 listed. This is still graphing, or what I consider graphing, but it's converting from rectangular to polar. And so if you were given the equations, how would you do that, the graphing? I would do all these by graphing, just going a blank graph here. If you're converting an equation or converting a picture, I would just type these in. So this says x squared plus y squared equals 4. No, x squared minus y squared, I'm sorry. So there's our picture. It's a hyperbola. And then graph in the answer choices to see which one is correct here. So A is cosine squared theta plus or minus sine squared theta equals 4. Okay, this isn't working. Let me try. Since it doesn't have an R, will it graph this way? Either way, it doesn't look good. So I tried it with a theta and an X. Let me try B here. Cosine squared theta minus sine squared theta equals 4R. And now let me try these back as thetas. Okay, you can see this one does not match. Here it is. That is not the correct answer. So B is for sure out. So A, we never got a graph. So I'm moving on. B is for sure out. Let's try C. R squared cosine 2 theta equals 4. R squared cosine 2 theta equals 4. All right, this one's saying must solve for terms of R. Let me try D first just to see if that's it. R cosine 2 theta equals 4. R cosine 2 theta equals 4. Okay, we can see that one doesn't quite match. It's close, but it didn't quite match. So that one's out as well. So we know B and D are out. So the answer is either A or C. C, it's saying the error here is it needs to be solved in terms of R. So what I'm going to do is I'm going to try something here. I'm going to solve for R. This R is multiplying. What's the opposite of multiplication?
Dividing.
So I'm going to type this in. I'm going to see if it'll work this way. R squared equals 4 divided by cosine 2 theta. Okay, it's still saying it must be solved in terms of R. We need to get rid of the square. How do you get rid of a square?
Square rooted.
Square rooted.
Okay, square root 4 divided by cosine 2 theta. Okay, now check this one out. What do you notice about that graph? How does that graph correspond to the previous graph?
They overlap.
They overlap. That's correct. So this one, the problem was I just need to solve to get R to a power of 1. That's what that was saying. You know what? I'm going to try one more thing. What if we just would have taken the square root of both sides at the start? I would have had. Ooh, I still would have to do it. That mathematically wouldn't work out. So what I did here is I said that R squared is multiplying the cosine. So we divided the cosine. And then I took the square root. The square root got rid of the square. And you saw that the graphs overlapped. Okay, so that would be the correct answer on this one. That was a little bit harder than I was expecting. Let's try this. This one will be easier because all the R's are 1 power, so I won't have any issues. So I'm going to hit the refresh. So this for graphing, it's just a blank graph here. Y equals 6. So I'm going to look for the matching graph here. This says R equals sine 6. I think I said that wrong. Dyslexic. 6 sine theta. There we go. 6 sine theta. See, that does not match, so A is wrong. B says r cosine theta. B is wrong. C says 6 secant. Ooh, there's a straight line, but it's not overlapping. D is cosecant. And this one overlaps. So the answer would be D. And 12, y equals x. So y equals x. And we try these. Sine theta equals cosine theta. Now this won't graph because I don't have an r. And if you don't have an r, you can just put an x and then it should graph. So this is not the correct graph. That's not the answer. So I try the next one. R equals sine theta. I think we just saw that over here. That's not going to be it. R equals sine theta. That's not it. Yeah, we saw that one. Let me extend it. So it's one of these two. Let's try r equals cosine theta. Since it has the r, that'll graph easier. It's not it. So by process elimination, it should be, it's looking like it might be this one. But I'll try it. So I'm going to type in sine theta equals negative cos theta. Now, when you're looking at that, nothing graphed. That's because there's no r. So you see how it says polar equations must have an r. So if you don't have an r, just put x's in instead of theta. Ooh, that's not giving me the correct graph either. I'm going to have to check on that, why we don't have a correct answer there. I don't think I have that one on the test, though. I would have had problems last year with that. So ignore that one for now. We'll come back to that. And here's the last few. Some more graphing. This time it's starting with polar equations. So I'll type this in, and we'll match graphs. And I'll figure out what's up on number 12 from a graphing standpoint. R equals 5 over 1 plus cosine. 5 over 1 plus cosine. Oops, I put an x. I shouldn't do an x. I should do a theta. There we go. So there's the graph. It looks like it's a parabola. And now we'll just type in our answer choices until we find the correct parabola. So x squared equals 10y minus 25. 10y minus 25. That's not it. So A is definitely wrong. B, y squared equals 25 minus 10x. Y squared equals 25 minus 10x is what it was. Minus 25 minus 10x. Ooh, that's the answer right there. So the answer would be B. Try 14. R equals 2 times sine minus cosine in parentheses. So R equals, I think it was a 2. 2 times the quantity sine theta minus cosine theta. Okay, and we want to compare it with these options. So x squared plus y squared equals 2y minus 2x. Zoom in here. Again, we found the right answer right away. This answer would be A. Okay, so I'm going to go ahead and let you take your test. I've spent a little over 30 minutes walking you through these problems. You'll only have 10. Remember, there's like 4 types of problems. So, or I guess you could call it 3 types if you consider all conversion of points, which I had that calculator where you either convert from polar to rectangular or rectangular to polar. That's the first type. You have a graphing type where you can graph and see which one overlaps. So there's that, and there were these where you just graph and see which one overlaps. And then there's also the polar distance type. Okay, so those are the 3 types of problems you will see on this exam. It's in PowerSchool Learning and Google Classroom. It's the Chapter 9 exam. If you want to go fill that out, go ahead and take that. You do have 10 attempts. I know it says 3. You actually have 10. So as soon as you take it, if you decide you don't like your grade, you want to retake it, you can do so. Do you have any questions for me before you start taking this exam?
How do we know which questions we use X and which ones we use theta?
Great question. So when you're graphing, if you have the letter R, you always use the theta. The only time I substituted was when it did not have an R. So like on 12, I was trying it on this one. They did not have an R there. And so that would be an example of doing that. Yeah, that's the only time you use an X is if it doesn't have an R. So as long as it has an R, you don't have anything to worry about. So like these have R's. You wouldn't have to worry about anything. Any other questions?